In this video, if we want to define what is polynomials, we should be aware of what do you mean by a positive integer exponents. So positive integer exponents means, so for sure, if I say positive integer, it should be a positive whole number. It can be 1, 2, 3, 4. Basically, you can say it's a natural number. And I'm talking about an exponent. So exponent means it should be something to the power. So in that case, basically I can say any expression which has a integer exponents for the variable. Let's say I have the variable something like x plus 2x cubed plus 4. So this is an expression. So in this expression, wherever I have my variable, so and that particular variable have the exponent as a positive integer. So which means this is a polynomial expression. Even if I have something like a x square plus 4x plus 6. So even this is a polynomial expression. Basically, it's also a quadratic expression. And even if I have, say, instead of using x, so let's say I have y equals to y cubed plus 3y squared plus y. So even this is a polynomial. Now, if I have something like x to the power of minus 2 plus 3x squared plus 2. So even though this has a positive integer for some variable, but also it has a negative integer for other variable. So which means, and the whole, I cannot say this is a polynomial. So this is not a polynomial. Not only the negative, let's say if I have x to the power of half plus 3 into x squared plus 2. So even here, the variable x has a power of fraction. So this half is a fraction, so which is not a positive integer. So that is the reason even this is not a polynomial. Even if I have something like 1 over x plus 3x plus 4, even this is not a polynomial because the reason is I have 1 over x. So if the x comes to the numerator, it would be like, say, x to the power of minus 1. So I should never have any like negative or fractional exponents for your variable. So that is what we say like a polynomial. Now, if I talk about a linear polynomial, if I say what is my linear polynomial, let's say p of x, the general expression for linear polynomial goes like ax plus b. And if I talk about a quadratic polynomial, the general expression for quadratic polynomial goes like p of x is equals to ax square plus bx plus c. Now, in these polynomials, if I talk about degree of the polynomial, the degree means the highest power of your variable, the highest exponents of your variable. In that case, the highest exponents of this for the linear polynomial is 1. So that is the reason I'm going to say n is equals to 1. If I talk about a quadratic polynomial, the highest degree is 2 because I have x squared. And if I talk about cubic, so the polynomial goes something like ax cubed plus bx squared plus cx plus d. So in this case, if I talk about the degree of this polynomial and the degree of this polynomial is n is equals to 3. So now, if I talk about finding the roots of the polynomial, let's say I take any quadratic equation. Let's say the quadratic equation is x squared plus 5x minus 6 is equals to 0. So if I want to find the roots of this quadratic equation, let me use the middle term factorization. I can factorize this and I can split the middle term something like x squared positive 6x minus 6 equals to 0. The reason how I can split is, so if I say 6x minus x, I'll get back the same positive 5x. And also if I multiply 6x times minus x, so 6x times minus x will give me minus 6x squared. So that is the multiplication of, even if you multiply your first term and the last term, you will still get the same thing. So that is the reason I can split this middle term something like 6x minus x. So now I can take x common. So that will leave me x plus 6. Again, I can take minus 1 common. That will give me x plus 6 again is equals to 0. This can be further written as x plus 6 times x minus 1 is equals to 0. So if you want to find the root, so which is x equals to minus 6 or x equals to positive 1. So these are the roots of the equation. So now if I talk about finding the sum and the product of the roots, the one way is you can find the roots, then you can add them up. So in that case, the sum would be equals to say minus 6 plus 1, which is nothing but, let's say, minus 6 plus 1 is positive 5. And if I talk about the product of roots, the product in this case is, let's say, minus 6 times 1, which is nothing but minus 6. So now, this is the one way to find the sum and the product of roots. Now, if I don't want to use this method and if I want some specific formula, and the formula goes something like this. So let me erase this part. And the formula to find the sum of roots and the product of roots goes something like this. So this majorly works for your quadratic equation. The quadratic equation, the general form looks like ax squared plus bx plus c. So in this case, y equals to, or p of x equals to x squared plus bx plus c. So where the sum of roots, the formula is coefficient of x. The coefficient of x in this case is minus b, minus of coefficient of x, which is nothing but minus of b, over the coefficient of x squared is nothing but a. So in that case, I can say the sum of roots of a quadratic equation is minus b over a. And the product of roots is a constant term. A constant term means a term without any variable. So in this case, a term without any variable is the c. So the constant term is c and the coefficient of x squared is a. So if you solve this without finding the root, let this be my equation. So in this case, a is 1 because the coefficient of x squared is 1 and b is positive 5 and c is negative 6. And as we know, the sum of roots is going to be minus b over a. So which is going to be minus of 5 over, and a is 1. So which is minus 5. And if you remember, we got the same answer. Even here, minus 6 positive 1 will be minus 5. So we got the same answer. And if I talk about the product of roots, the product of roots is c over a. And the constant term here is negative 6 over a is 1. So which is nothing but negative 6. And we got the same answer. So this is the best way to find the sum of roots and the product of roots. Now the question arises if the sum of roots and the product of roots formulas are only there for a quadratic equation? Absolutely not. So there are formulas for which works for any polynomial. Let's say I have any general polynomial, something like this. Even if I talk about a cubic polynomial, let's say ax cubed plus bx squared plus cx plus d. Or even if you talk about any fourth power polynomial, ax to the power of 4 plus bx squared plus cx or bx cubed plus cx squared plus dx plus e. So this is to this is the fourth power polynomial with the degree of this polynomial is 4 and the degree of this polynomial is 3. So here, instead of a, b, c, and d, they have used an minus 1, an minus 2, something like that. So something like, say if I have a fourth power polynomial, something like a4 into x to the power of 4 plus a3 into x cubed plus a2 into x squared plus a1 into x plus a0. So this will be my polynomial looks like. So in that case, the sum of root, the general formula for sum of roots is going to be minus coefficient of x to the power of n minus 1. So the coefficient of x to the power of n minus 1, if I talk about degrees being 4, So x to the power of n minus 1, which is 4 minus 1, which is x cube. The coefficient of x cube in this case is b. Divided by, so in this case would be a n minus 1 divided by the coefficient of x to the power of n. So which is a4, or you can say a. So in this example, it will be a n. So similarly, we do have the formula to find the product of roots for any polynomial, which looks like minus 1 power n into a constant term, means a term without any variable. So in this case, it would be a naught over the coefficient of x power n, which is a. Let me take some example. Let's say I have 2 into x to the power of 6 plus 4 into x to the power of 5 plus so on. Let my last number be 9. So in this case, if I want to find the sum of roots and the product of roots, the sum is nothing but, as we can see it, minus the coefficient of here, the degree of the polynomial is 6 because the highest power is 6. So the coefficient of x to the power of n minus 1, which is nothing but x to the power of 6 minus 1, which is x to the power of 5. So what is the coefficient of x to the power of 5, which is 4, divided by the coefficient of x to the power of n. So the coefficient of x to the power of 6, which is 2. So that is the reason the sum of roots of this given polynomial would be minus 2. And now if I talk about finding the product of roots, the product is minus 1 power n. So n is nothing but 6 here. So minus 1 power 6 into a constant term. A constant term means a term without variable, so which is 9, divided by the coefficient of x to the power of n, which is x to the power of 6, which is 2. So if you simplify this, minus 1 power any even number would be positive 1, and which is 9 over 2 will be your product of roots. So this is how you can find the sum of roots and the product of roots for any polynomials.